Good afternoon, everyone. Thank you for attending this afternoon's presentation. Blue will be presenting today on Tomb Raider, Automating Data Recovery and Digital Forensics. So I have the absolute honor in going ahead and starting this presentation. Of course, what presentation would be complete without a few prior announcements, such as going ahead and thanking you for being here. We do like to take a moment and thank our sponsors, whom with this would be absolutely impossible to be here with you and present. In particular, we would like to thank our diamond sponsors, which are LastPass and Palo Alto Networks. We do have a couple of gold sponsors too that we would like to go ahead and say thank you to. And that includes Amazon, Intel, and Google today. It's their support along with other sponsors, donors, and volunteers that make this event possible. So, quick reminder, please do keep your masks up during the presentation. We are trying to keep everyone safe, so we appreciate your support. Cell phones. Go ahead and please make sure your cell phones are not only turned into like a vibrate mode, but also please try and keep them in your pockets if possible. We are recording this going ahead, so we'll get it posted online. There's really no need for you to go ahead and take photos or videos. You'll have the ability to see all this afterwards. And just a reminder of BSides policies. We do request that you do not take photographs without explicit permission of everybody in the photo. Of course, we are trying to be sensitive to those who are in unique situations and prefer not to be photographed. So please try not to take photos here without explicit permission of everybody in the photograph. So, also as a reminder, wow, I was ahead of myself. I got all of that. All right. So without further ado, I will go ahead and turn it over to Blue. Blue, thank you so much for being here, and have a nice afternoon.
Thank you very much. Glad to be here, man.
Oh, that's
what. What? Did you?
I knew I forgot something. Oh man. Okay. So please, if you're going to go ahead and ask a question, there is a microphone in the middle of the room. It's not that we can't hear you. It's because it's being recorded. Those who watch the recording afterwards will not be able to hear the question. So we do request, if you're going to ask a question towards the end of the Q&A session, please come up and use the microphone in the middle of the room so we can capture that. And of course, Blue, it's always nice if you can repeat the question when they say it, just so that we go ahead and capture it as well. So thank you.
Yeah, I'll repeat it. No problem. This is still good for Mike, right? You guys can hear me? Back of the room, you guys can hear me too? Okay, great. Cool. Without further ados, I'm really glad to be here, and thank you guys all for coming. So, I'm going to be talking about a tool I made today called Tomb Raider. Much like the game, there will be a few jokes about that, but overall, I hope the naming of it becomes obvious soon enough. Automating data recovery and a little bit of digital forensics as well. So first, obligatory introduction. My name is Blue. Yes, like the color. If I were green, I would die. This guy, he gets it. It is a difficult life. Pronouns are she, her, or whatever. But yeah, and if that's a problem, you get the bad Kermit. We don't want to see that. Otherwise, we're good to go. So thank you all. I like hard drives and data recovery. That's the topic of today. I started on my own broken hard drives. I think many of us have these. And we just had it laying around. And I figured, I'll figure out how to do this and work from there. Since then, I've started doing all manner of other ones. The ones I could find at local hacker spaces, in the dump, in the trash, anything really. And yeah, let's talk about how you do what I do. So, first we're going to talk about an overview of everything that this tool does. We're going to talk about the steps of data recovery and a little bit of the background of that, and then walk you through how we're going to automate those tools, those steps, and improve them with Tomb Raider. So, we start with hardware prep. You have a broken hard drive. How do you go from that to an interface you can work with? Afterwards, how do you image the drive? We'll talk about what that means and how to do it. Then, how do you possibly recover a file system if you've lost it? And if that doesn't work, or if it does work, how can you also get extra deleted files, determine what a random piece of memory is, something known as file carving, which I'll go into in a minute. And then afterwards, some stuff where Tomb Raider really shines is post-processing. So handling all of this data that you get from a given hard drive. You might have terabytes of data from even a small, like 500 gigabyte hard drive. How do we deal with that? How do we sort it out and actually find out what's ours, what's not? Or if you're dealing with a random dumpster-drive hard drive, how do you figure out what's interesting and what's not? How do you figure out what's actual user data and not just Microsoft system files? Additionally, if you're looking for it, you can also crypto salvage and look for if there's any evidence of cryptocurrency on that hard drive. So, that won't do it. First, again, why would Blue do this? Well, there's lots and lots of reasons. You are already here, so I've kind of succeeded. Congratulations, you're now trapped. You now have to learn about data recovery. Just kidding, you can leave if you want, but whatever. Point is, I usually don't like asking why, because I mean, I'm already here. I'm already trying to learn it. I digress. A lot of us don't want to pay tons of money just when we could do it ourselves. We have a lot of broken hard drives. I did. I didn't want to have to shell out $500 for them to maybe not even get anything. Or especially if I have my own private data on there, I don't want to just give it to someone and be like, hey, try and get this. The only way to know if you've actually gotten it is to get your data. So that is a privacy concern. There's lots of reasons. You might also just want to explore like I've done, where you find random hard drives that otherwise would have been disposed entirely and figure out what was on them, what is the story there. Additionally, if you are interested in digital forensics, I am happy to announce that you cannot do forensics if you don't have a hard drive with data on it. If you can't get the data off of it, how are you going to do forensics on it? You can determine, oh, this hard drive got hit with a sledgehammer, and that's about it. But if you can't recover the actual data from it, it's a bit of a bummer. So I consider this a stepping stone. Additionally, better programmer and a better hacker. So first, what you can do, here's what you can do with data recovery. More than 90% of the problems with hard drives with minimal effort, you can just solve them really easily from my experience with ones that are literally e-waste. Thrown away, and I have no reason to believe that most of them were, I have no reason to believe that they were functional, or rather, I should say, many of the hard drives I found little errors on them that were really easily fixed, but I presume people threw them away because they didn't know how to fix them. And now, with this tool, I was just automating it and going through it and finding all this stuff that people didn't realize was still there. They thought it was just, oh, it's not booting, this is happening, why is that? There are, of course, the other 10% though, 5%, which are harder software problems or hardware itself. Like if you did hit it with a sledgehammer, you might have this problem where you damaged the board on top of it. Or in case of even worse cases, you really destroyed it, in which case, well, I can't cover that in this talk. The other 5% as well, unfortunately I only have so much time, so ask me about it later or in the Q&A if you like. That other 5%, the 5% that we cannot really recover, we've actually seen some DEF CON talks about them. If it's properly encrypted, if it's completely overridden with zeros, or random data or just new files, it's going to be gone. If it's blown up and the platters are broken, if it's melted into slag, well, we don't really yet have the ability to do that unless maybe you have a really serious microscope, like and crazy resources and patience. Additionally, some stuff with solid-state drives. I will cover that later if you guys want to ask questions and talk about it. Anyways, intentionally destroyed drives. This was a hard drive that I found in the San Francisco dump. And you'll notice a lot of things about this. First off, all the pins are really weirdly bent, and the ribbon cables on the left are cut. There's cables that are directly cut without much damage to the rest of it, which is a little unusual. You would expect if this just got dropped on the stairs, it wouldn't really look like this, and that's because I have reason to believe this was intentionally destroyed. And they intentionally tried to destroy it, quote unquote. Because in reality, all I had to do was find another hard drive with the same model, replace the board, and then I could read off of it just fine. Because the underlying thing, the underlying data storage device that had all the files was still there. It was a little beaten up. They presumably threw it against a wall or something, but it was working just fine. And on that, interesting things. This hard drive contained data from this guy who's on the San Francisco Water Transit Authority. We had some information on boat requirements and specifics for vessel voyages and all manner of things that had to be ready for. Additionally, random stuff like this presentation, which has wingdings in the title, I'm not entirely sure, and making ferries a viable transit option. This guy's article on feet of ferries, which is a little bit of a weird name, but I'm not going to judge. So Steve here feels very strongly about ferries. He would choose ferries if one day the day came down to it, so good for him. Other stuff you might find, interesting account info. First name, last name, home addresses, phone numbers. This is a massive address book. It keeps going. And these are just random names of somebody who presumably was an accountant or secretary or just a normal person. And they left this there thinking it would be gone. It was not gone. There are a scary amount of data on these things if you're interested in finding stuff like that. I don't encourage using it for bad. But if you're interested and you just like finding stuff like this, like I do, give it a shot. Oh yeah, psychiatric records of this guy's medical history. That was pretty rough. That was quite a story. I blurted it out, but yeah, that's a thing. On a brighter note, also found copies of The Room by Tommy Wiseau and other wonderful movies and films like that where you can just get for free because why not? It's on someone's hard drive. If you've already got stuff on your hard drive and someone else got it, congratulations, now they can get it using this tool. You also find glitched images like this, which can have little stories of their own. Like I like the soccer guys who are like really upset about their image getting glitched out and they're trying to argue it back. I have no idea what happened with the AOL image on the left or the ducks or whatever that is. Curious things like this, interesting and foreboding ones like this, and the terrifying monstrosity on the top left that looks into your soul. Little Darla has a treat for you is what that one in the middle says, which is, let's continue to something less scary. Oh God, no. Anyways, this guy, I have no idea where he came from, but he was also on a hard drive. His name is Craig. And at first I was terrified of Craig because I was like, I mean, no offense, Craig, but look at him. But he actually just has a little spatula and a little skillet on the left there. And I realized he's just making a little brekkie. And he's misunderstood. And now I love him. Anyways, you can also find Dogecoin and Bitcoin, whatever. Slightly less valuable now, sorry guys, but I have found a few of those and made money, but I'm not sure if that or Craig made me happier. All this from these intentionally destroyed drives. You may have one like this, you may have one that's less damaged. So with that said, let's get back into how to do this. How Tomb Raider can automate it, how you can find your own little treasures, how you can recover your own personal data, stuff that is important to you. We'll give a brief description of each bit and how it works, because I sure didn't know all these steps beforehand. And then we'll cover how Tomb Raider automates it. We'll cover how we can make that faster, optimize things, speed things up, and walk through it. To do that, I'm going to employ what I call the library analogy. And to explain that, first imagine you have a big library. This library is your storage device, your hard drive. It has all of your documents, all your downloads, all your pictures, somewhere in it. You have it organized in your own specific way using a catalog, an index. Just like you might go to a library and look up where is the fiction or nonfiction, where are the books by Jules Verne or Edgar Allan Poe's poetry. You have documents, downloads, desktop, pictures, media, music, everything like that somewhere in your library of your hard drive. This is your file system, and without it, it becomes really, really hard to find stuff. There's a lot of books in there. So this is how we're going to represent it. And with that said, let's talk about deleting files. No data recovery talk would be complete without deleting files, right? So library, storage device, books, the data, and our catalog is our file system. What happens when you actually delete a file in your file system? The normal way: throw it in the recycle bin, empty the recycle bin, throw it in the trash, empty the trash, whatever, yada yada. Well, unfortunately for those who really want it gone, that is not going to actually delete anything. That is going to remove it from the file system, but not off of the hard drive itself. It's never deleted. It's only overwritten. This is as if you remove something from your catalog, from the system that stores it and lets you find it, but not from the shelf, like that. That never happens unless you really, really try hard to get it to do that. Sometimes it's easier, but by default, that's not the behavior. And default behavior is what most people end up using. Most people who I read these drives from were using, presumably. And if it's still there, well, let's just, take the bookshelf and handle that later. So, let's get your device ready for Tomb Raider to run on. I usually just plug it in to my desktop. I recommend not plugging in random drives into your work desktop, because that is basically just as bad as plugging in random flash drives into your desktop, and we know that's bad. Let's not do that. I usually just use a normal motherboard connection on my desktop to do this. You can use a lot of adapters, however, that work just fine on most computers. And you may not be able to recognize it in your file system itself, but once you find the identifier for it, which I describe on the GitHub page, and at the end of this presentation, you can see the link to that page where you can download the software and deploy it and everything. That's all documented along with the software. It's got usage instructions. And even if your file system doesn't recognize it, that's how you can find it. It works best on Linux. I did develop it on Linux, so yeah, sorry, maybe future development in the future. It's so much easier in Linux. I can just download all the stuff, and there's only a handful of commands to set it up. If I have the time, I'd love to deploy it for other OSs, but you can also just help me make pull requests on the GitHub repository. Please. Anyways, imaging. Once we've got it plugged in, once we've got it recognized, using Tomb Raider and the instructions on the repository, we want to image the drive. What is that? Well, basically, we take the entire library. Why would we do that? Because it's pretty big, and we don't really want to just have a big disk that we have to plug in all the time just to read it. It might get damaged. It might get damaged. It might actually get worse over time the more we mess with it. And that's no good at all. We want it to produce the same results every time. We want to be able to copy it if we can, so we don't lose anything else. So Tomb Raider uses a tool called Safe Copy to incrementally get as much data as possible from the drive. It uses this incrementally, makes a bunch of passes through it, tries to get as much as possible, even from areas that get damaged or corrupted. Safe Copy is a wonderful tool, so thanks for that. It's the only part that requires the physical drive. After this, you can unplug it, throw it in a blender, maybe don't, but you know, you can. Anyways, now that we've got the entire library in a file on our computer, we want to try and get the catalog for it. File system recovery. We want to find our way to recognize where our documents are, to find out if we still have pictures, what are the audio files. It's pretty helpful to have our catalog. We've likely spent a lot of time organizing it. It's not explicitly necessary because the books are all still there. We can still take the bookshelves, but it's very, very helpful, and we want to find it if we can. So we start with that. Metadata. We use TestDisk to get a set of these files. TestDisk is another lovely tool. We make use of a lot of them to get all of the files that it can from a variety of supported file systems and recover those if at all possible. Because, of course, if we don't have to go through those bookshelves on our own, let's not, because we'll see later that we'll see in just a second on that topic, it's not too fun. So, start with TestDisk. Afterwards, we do file carving. This is if we did have to go through it manually. This is if we don't have a file system and we did take the bookshelves. If we do that, we want to look through them for stuff that still looks like books. We want to discard the catalog entirely and say, screw that, I don't trust anything, I'm just going to look through all of my bookshelves, even if it looks empty, and see what I can find. And that's what we call file carving. You are carving out unallocated space. You're carving out of this empty space, this randomized data maybe, actual meaningful data. We use headers, footers. There's a lot of different mechanisms to possibly get this data from it. It's super fun. Let's go through an example just to show how fun it is. So, JPEG. This is some of the markers for JPEG from Wikipedia. I don't know if you can see this, but it's okay if you can't. There's just a lot of different indicators of hexadecimal encodings, whatever. Stuff that represents the start of the image and the end of the image. And here's an example image. In this example image, you can see all sorts of different jumbles of hexadecimal characters. And if anyone can spot the start of the image in this, on the right here, let me know. And raise your hand. I'd love to see that as an exercise. Yo, what's up? Crap, I can't hear you. Okay. Wow, they found it. It's in the top left. Good eye. There's this random octet right here, this random set. That is the beginning of it. Obviously, it starts with that. And then there's another code way later down in the list that goes right next to that. And that's another indicator that this is a JPEG. Very helpful. Not very easy to spot. We do have to go through all this list checking for these things. And then at the end of the image, we have to look around for the code that indicates it's over. Because we not only have to know if we're carving something out where it starts, we have to know where it ends. We don't know how big the image is without this. So you look for a code that indicates that. And you can find that right there. Now, let's do that for every extension ever. Let's find Wikipedia pages, if they even exist, for stuff like RAR files and .aa files and whatever else. This is a list of like just the ones that start with A and just the ones that are at the very beginning of this tool we'll cover in a minute. That'd be great, except it wouldn't. It would suck. So we instead make use of and use our own tools as well in combination with this to recover all extensions that are supported from that uncatalogued space, the space without an index. This tool is awesome. It covers 480 file extensions and file families. Those are like audio, music, videos, archives. And as you might expect, for something that's just looking through random data for anything that looks like important data, it's going to make a lot of resulting data. If I gave you a ton of specifications, even if I gave you random noise, you are going to find stuff that looks like it. There's likely that we will find something that looks like a JPEG, even in random noise eventually. And don't worry about the interface on the right. It's this stuff is very thin, small text. Let's just emphasize that there's a lot of extensions here, and that's the interface that PhotoRec provides. Unfortunately, a lot of the data that's produced isn't always meaningful. You get false positives, you get data that is Microsoft system files, you get random log files, corrupted data, so that's not useful. Also, your computer's out of storage space. Sorry about that. This is a lot of data that's getting downloaded from OneDrive. You are getting the disk image, the file system, and now these carved files. And that's a lot of storage space. There are, of course, options in Tomb Raider, so you don't have to worry about any storage space, or as little as possible. You don't have to make a disk image. You can just read from it directly. If you're limited by space, you can skip the carving entirely. You can just get file system. You can literally run it with everything disabled, and it'll just say, great. Well, I don't know why you did that, but great. So let's condense everything. Let's make this a little bit smaller, and let the raid finally begin. We have our disk image. We have our file system. Well, we might not have our file system. That's the one we might not have, just because it might not be there. And we have our carved files. First thing we can do, we can get rid of the disk image now. We already got an image of it, and if we are low on storage space, we are going to get rid of the disk image so that we don't have to worry about it, because the disk image is the entire size of the drive. If you have a terabyte drive and you only have 200 gigabytes on it, it's going to be a 1 terabyte file. If you have a library that's full of books and a library that's empty, they're going to still be a library. We don't want that. So we get rid of it if we can't fit a library in our other library, I guess. And then we have our file system and carved files that we want to combine into something better. A tomb file system, which we can raid. Get it? Yeah. Okay. And then we can continue with a more efficient representation. So, we're going to make a lot of upgrades and changes for this, for making it more rateable. We're going to start with flattening everything into one directory. Instead of having this massive tree structure, we're going to represent each location of a file with its directories. It'll end up with a big file name, but this will also represent where it's from without us having to go through every single subfolder in every single folder and so on, trying to figure out where something is. You'll just get a big list of everything. We'll also sanitize the file names, remove stuff that would break the program, because Unicode is, God, it's a nightmare. We'll create an index, and that will contain the file name and the hash of the file name. No, the hash of the content. Sorry about that. This should help make things a lot easier. But why do we need to get a hash of the file content for this index? Well, first, a quick overview of hashing. Hashing is a one-way operation. If I have a hash function, it's going to generate a unique identifier on the right. So if I have Fox on the left, it's going to produce that weird string of digits on the right. I hope you can see this in the back. Sorry if you can't, I'll narrate. And second, we may have something like the red fox jumps over the blue dog, which would also produce a different operation. Even if we change a tiny bit of it, it is going to produce an entirely different result. Now, I know some of you are very fond of cryptography. I'll say hashing is not encryption. There, please don't kill me. Anyways, hard to find collisions in this function. These are the properties of a hashing function. There are pretty much two. The third one's kind of a repeat, whatever. I digress. We use a hashing function to get identifiers. The hashing function has several properties. Firstly, it's hard to find collisions. It's hard to find one piece of data that produces the same output as another piece of data. It would be hard, very, very hard, for me to find another sentence that would produce the same output as the red fox jumps over the blue dog. I'm sure if I tried very, very hard and used a lot of resources on something that's not very secure, I could, and people have. But for our purposes, we don't really care about that. It's also hard to reverse. So if I just give you this random data on the right, you can't really go back. And especially since these things tend to be very, very random or very, very different, you can't really determine much about the input from the output, or really anything at all. So even if I have one modification, like a typo on the second line, we're going to get an entirely different output. Why is this relevant at all to what we're doing now, and why is that useful? It seems like we would want to know the input. Well, this produces a lot of very small and, for our purposes, unique identifiers for each of our books, for each of our files. These books or files are just data at this point. They don't really have file names. We only have an extension. So how do we name them in a way that we can compare them to each other, compare them to stuff we already have? We use hashing. And specifically, we use MD5, which is a fast, small, and widely supported one. We use this to remove duplicates, as well as some other functions we'll get to later. And, well, why else would we do this? Well, to do that, we'll cover about hash sets. On the top right, just for the record, I usually keep the small stuff, not the stuff that's really small that you might not be able to read it. That's because it's not that important. Don't stress it. In the top right, there's a bunch of hashes of random files, and in the bottom right, we have a bunch of different sets of hashes of those known files. Because some books are boring. Some books are Windows systems files. Some books are log files. Some of these files are not interesting. If you want them, you can enable Tomb Raider and it'll get them. But most of us don't really care about that. If we were trying to just get our own data back, we don't want to be saying, oh, finally, my collection of Metallica, and it's just the dun 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 from Windows booting up. So all these things we don't really care about. But how does hashing come in? That bottom right picture is of what is known as the NIST NIRL. It is a wonderful online repository with tons of known files. So these Windows system files, they exist on everyone's Windows system. There have been lots of operating systems, and we know what files they have on them. So what do? You get them all together, you collect them, and you provide them for anyone to use. By doing this, you end up with a ton of hashes of known boring files, stuff that we don't care about, stuff that we can ignore and save us some time defining what we do care about. We use these sets to considerably reduce the noise, get rid of all that garbo, and get us some more important stuff to continue onwards. Any ideas for some pitfalls for this? Where this might not exactly succeed? Really, ideas, questions? Well, earlier we saw what happened with typos. Even small modifications can produce entirely different hashes. And unfortunately, if you're recovering data, you're going to end up with a lot of corrupted data. So that's going to be entirely different, even if there's just one byte flipped, and it's not going to be in the hash set anymore. So while this has been great, it's basically taken this massive library and removed one of the bookshelves from it. We still have quite a lot. So what do we do from then? Well, we sort it as best we can so that we can comb through it and figure out what we want to figure out based on better categories like music and videos and stuff that might have been on the desktop or other stuff that was created later in the computer's time span, if you can. We already know how to classify and find what type of extension a file is using file classification, using photorec from earlier. And we can also create subclasses of those specific, using those specific extensions, like, let's say we have a, what's a good example? You might have a PNG or JPG file, and you might have GIFs. These are all subclasses of an image. These are all lower on that hierarchy. So we would want to sort them into different things, just so we can better and more easily look through them. This is just extension classification. We're simply taking the extensions and we can organize them into categories based on what type of extension they are. It's nothing crazy. It is, however, very tedious, which is why Tomb Raider does it. We can also use content classification. We can open up the books, we can look through them, and figure out if it's a fiction, a nonfiction book, if it's a image, if it's a piece of media, if it is random noise, and it doesn't actually seem like an image at all, or rather, a file at all. And there's a lot of different ways of doing this. For ours, we use libmagic. Those who are familiar with Linux will know this thing called the file command, but it's not super relevant. The point is that there's a lot of methods to determine the data type based on the data of the file. Determining what type of book this might be based on the pages. We use both of them. And afterwards, we end up with something that represents our images, our audio, our video, our document files, our program files, system files, and so on. We end up with an organized representation of data that was on the drive. From this random massive assortment of images, we end up with, keep on calling it files images, with this random assortment of files, we end up with something that is our own directory structure, our own better file system. It also flags it for anomalies the best it can. So if you have something that looks like a JPEG at first, but then has a bunch of plain text in it, well, that's a little weird. You should probably look into that. It's not an extremely data forensics heavy approach, but it can help save you some time if you're just looking for a quick scan over things after you've done data recovery. So, from then, we have all this data. What do we do with it? Well, we can still add some other stuff to trim it down. We can blacklist. We can say, hey, I don't actually really care about program files at all. I want to be really judicious about it and just get rid of all of them. Or I didn't have any music on this computer, so let's just get rid of all of that too. Or let's say instead you're a photographer and you've lost your hard drive got damaged and it has all your photos on it. You don't care about program files. You don't care about music. All you want is to whitelist the images. All you want is to get the images back from this drive. Additionally, you could probably skip a lot of other steps. You could skip the file carving if you can find the file system because you don't care about your deleted images. You could skip the imaging process of the drive if you really want. And you can skip every other thing too. Tomb Raider allows you to do that. And lastly, it runs entirely on its own. So once you start it running, this operation, which can take hours or even days to do, all of this, it will just go automatically. I like to just start it running the night before and then check on it for breakfast and find other Craigs or other such content on there and be very confused. So that is the walkthrough of what Tomb Raider does at the moment. What is it going to do in the future? A lot of this stuff I'm going to add as soon as I possibly can. I've been, a lot of my time recently has been focused on this presentation. But first thing I'm going to do is rebuild a better version of the original file system. This would be essentially a better library. So instead of one that might be not very well kept, a library or hard drive that is very disorganized, we can make our own. We can get rid of duplicate data. We can have a better way of looking for what we want faster. A lot of times computers seem to have a very hard time finding files in massive sets, which frankly doesn't really make sense to me because we can always do other stuff like, create an index. Yeah. But anyways, we can replace duplicates of files with links to those files. We can get rid of these long file paths, these things that are under a ton of different folders. We can include the files that we otherwise would have had deleted, and we can uncompress stuff. This is all just lovely, nice to have afterwards. I'm working on this now. It works just fine already, promise. And these are features that I'm planning on adding back. So if you had a system that was damaged or destroyed, you could plug and play, and it would be exactly like you remembered it, rather than just being something for exploration. Otherwise, I'm thinking of adding in entropy classification. This is, entropy is a measure of how random a file or set of data is. So a random number, very high entropy, but a Shakespeare's works, low entropy. This is useful to us because we can compute a number 0 to 8 that actually measures the entropy. And use that number to maybe determine if something is noise or not noise. Which is great, right? That sounds very useful. Why didn't we use this earlier? Well, there's a bit of a problem with that. Unfortunately, that a lot of file formats, like encrypted file formats, are very good at encrypting. They produce things that have very high entropy, very high, seemingly random data. So you might have 8 for completely random noise, which is actually kind of hard to get because nothing is ever completely random. And you might have 7.99997 for an encrypted file, or a compressed file. Because, of course, it wants to try and take this long, organized data and compress it into a very compact, unique representation. Additionally, on another note, the file formats we use for images and audio, MP3 and JPG, are also very good at compressing. So they're basically the same. So I didn't use this in Tomb Raider because I kept on finding that there was just too many false positives. But I'm still working on it, and I am hoping I can use it to filter out the signal to noise ratio a little bit better. So yeah, that's it, everybody. That is now, I guess it's time for the QA and resources. We use a ton of software for this, for Tomb Raider, and special thanks to all of these amazing places for the wonderful software and wonderful data sets I got to use to make this thing work and put together a lot of pieces that would have taken me ages to do otherwise. Additionally, special thanks to everyone who throws away hard drives without destroying them, Scott Moulton, Noisebridge, the Hackerspace, and lastly, Laura Croft. Thank you, Tomb Raider. So yeah, I guess I said that was it, and then I had some more to say, but any questions? Yo, can you come up to the microphone so they can hear you? If you have questions, can you guys come up to that microphone and ask? I'd love to answer them. What's up?
So big files with high entropy are probably compressed.
Wait, sorry, can you?
Big files with high entropy are probably compressed. Small files with high entropy might be interesting, things like SSH keys.
I agree. So they said big files might be something that's compressed and have high entropy. Small files might be something like SSH keys or stuff that's important. I agree. Thank you. And at the moment, that's actually covered by the tools that we already use for classifying. So the content classification and extension classification that would look for .key or .pem files, works really well. And I find those all the time. They're like one of the most common things I find, along with shadow files, which are fun to test out on another note. But yes, I agree, and that's part of the reason I want to implement it, so I can use that sort of stuff to shorten things down, or at least provide an option saying, for those who want to use it and say, really, really, really crank down on the noise, in which case they could just remove all of the files with a higher entropy. Anyways, yeah, what's up?
So first I just want to say this is awesome. This is so cool.
Thanks so much. I really appreciate it. I really love it, and it's been a lot of fun making it. So thank you so much. That's very nice.
And my question is, when did you start approaching this as a signal to noise ratio problem? And what did you use to kind of get yourself there?
When did I start treating this as a signal to noise ratio problem, and what did I do after that to like work from it? Okay. Basically, I would recover data, and there would just be so much. There would just be tons of files. And even on stuff where I knew more or less what it was or what would be there, because I would find the file system and I could look and see what were actually documents or downloads. It would just be some office computer. There would still be like a massive amount of Windows files that would just dwarf any of the user data. At that point, I was looking through it, and I was spending all my time trying to find actual relevant data and stuff that was added by the user, not by the computer. That I was like, I gotta work on improving this. So I spent a lot of time, there was a lot of time spent on Tomb Raider just doing that, and working on shortening it down, making it so that you can actually process it, because there are a lot of tools that Tomb Raider uses. These problems are not, unsolved for recovering data. And the problem is that people don't know how to use them, and they produce so much noise that they can't really use them. And that's why I made this. I wanted you all to have a tool that you can use where you can just plug and play and run it on any sort of hardware.
I am so looking forward to using this. Thanks again for the presentation.
Thank you so much. I really appreciate it, man.
So I looked up your tool before the conference when the description for the talk was posted. Just looked super great.
Oh.
Looks like a really awesome wrapper around a lot of other tools that we all use very frequently.
Thank
and so
you so much.
I'm excited not to have to do it all manually anymore. But I couldn't find any good descriptions on how to use the tool or how to set it up, especially where it uses so many different tools. You probably got to set it up just right. Kind of what's the process you're looking at and creating that kind of documentation so we can actually go and use this?
Absolutely. So they brought up a very good point, and it is that when they looked up the tool like a few weeks ago, it didn't have as good documentation. You're totally right. It's because I was making these slides. And I have updated the README since then and other documentation to make that better and support more stuff. Now that I'm done with this presentation, I'm going to be improving that even further and continuing my development on that in my free time. So you're totally right, and I'm sorry I wasn't there earlier, but thank you for looking. I'm glad you checked it out. I guess I didn't expect anyone to be looking at it much earlier, so it caught me off guard, but I will, I'll be improving it a lot more. I've already added some documentation on these steps and some usage and installation instructions.
Thank you.
My pleasure, thank you. Any other questions? Does anyone else want to add? We still actually have a lot of time. I'm a little bit early. So if anyone wants to know about stuff that wasn't very clear, any possible future features, bring it. I'd love to hear about it. Hiya.
Hi. So for some of the maybe more interesting things you found, like the diagrams.
Can you speak up? I'm sorry.
Sure. The diagrams you found, the architectural diagrams for the water system. Have you done any reporting to the owner of that data, or thought about how you might do some disclosure?
I haven't been able to find the owner of the data. Also, fortunately, those diagrams they seemed to be. Yeah, there wasn't any actual compromising data for their systems on there. just interesting stuff regarding the technical specifications of how ferries work and how the San Francisco Water Transit Authority ran their system? That's a very good question, though. I have reached out to a lot of owners of these drives. When I found, like, when I'll find all their data on them, and I'll just be like, oh wow, there's like an entire, this is this person's life. These are family pictures and so on. To clarify, the question you asked was, have I contacted the Water Transit Authority about this data? Anyways, sorry I didn't say that earlier. There have been a lot of people that I've found their hard drive, and I have been able to find contact info. Tried reaching out. Unfortunately, usually they don't respond, or it's out of date information because it's been in the dump for years, and I just randomly dug it up. But yeah, I also run a side business doing this, so I can more like directly help people and help them get their data back without it being any like problems, without there being problems. What's up? Do you have a question?
Actually, I do have a question.
Wonderful.
I was interested to know, only because you're so intimate with the topic, what is the current state of backlog in like organizations who are trying to get through these petabytes of data using these kind of tools? And are you finding the tools have been effective in trying to help them, or it's been a few years since I've looked at the numbers as to the backlog?
The backlog for
for example, when they're trying to government agencies or local law enforcement are trying to go ahead and create a case against somebody using the digital forensics, and there's usually these backlogs of years sometimes to try and get a hard drive through for analysis because it's so manual in many ways.
That's a really good question. Thank you. So they asked, what does it look like for existing enterprise implementations of data recovery and digital forensics? I can only give an approximate representation because I have not worked as a digital forensics person. This has just been my fun learn how to do data recovery thing. However, I did get familiar with that because my roommate does digital forensics, and I was like, hey, what do you think of this? And they were like, oh, fuck, that's great. And so I guess my answer, take this with a grain of salt. I think they just pay for the time. They just spend a lot of time going through stuff. They have to do some stuff in a manual fashion because because it's just such a strict legal process. So, like, full disclosure, you couldn't just be like, Your Honor, here's my rated tune, arrest that man. Like, that's not really how it works exactly. You have to use like the original image, you have to use all this stuff, but you also have resources, and you're still gonna have to look through tons of files, and you're still gonna have to try and recover all this old data. Why not save yourself some time and automate the hell out of it and find as much of it as you can immediately using this? And that's what I made it for. Not as a very good first step for that, and a final full solution for anyone else. So thank you for that question. It's very good. What's up?
So when the hackers all go back home and everyone's in their local municipality,
Yes.
where do you suggest we look for busted hard drives?
That's an amazing question. Oh, I love that question. Okay, so when hackers go home, okay, I have 2 minutes. When hackers go home, how do they find hard drives? It's a great question. So it depends where, there's some places where for the dump specifically, you usually have to know people to be able to like look in the dump and find them. I know people and made friends with people who work at the dump, which is great. However, that's awesome. There's tons of ways. So I only have so much time, so I'll go through some of them. eBay. Tons of stuff. You just look for the ones that are like broken or for parts, and then you just can buy like a stack of 20 of them that are from laptops for like $50. It's the best. You can go to garage sales. You can go to old offices. They're always throwing away computers. You can go to places that have e-waste. which is also old offices and other companies, and if they have public access to their e-waste, which sometimes they actually do, and it's a little bit annoying, if you work at a place that has e-waste, just go there. And then you can find a lot of hard drives and other such things in there. If you find anywhere you might find broken computers usually have hard drives. So I went to Noisebridge, special thanks to them, which is a hackerspace. To translate, that just means that it is a big workshop for anyone who wants to build stuff, hack stuff, and people donate stuff to it all the time. They had tons of just broken computers and shells of them, and I would just be like, all right, time to go get some hard drives. And they used to have a lot of hard drives in those dead computers. Now they're all mine. And I am using them for practicing and for testing this and practicing this. Don't worry, I'm not actually taking all of them because people should hack on them and do also their own stuff with it. So yeah. Oh, cool. Okay. All right. I'll take an hour to explain the rest of this question then. So, yeah, hackerspaces are basically workshops where you can do that, yada yada. And people just donate spare computer parts to those. You can go look through those, find hard drives. Garage sales. People just throw away old computers because they don't work. And it's because the hardware was broken or, broken. You can go to, what was it? Craigslist. Lots of old stuff there. Craigslist is like, I swear, Craigslist is like the black market, but it's like not the black market. You can find everything there. What was I going to say about garage sales? Just you can go through the literal trash of places that are near corporations. That's not very fun though, because you can usually find them in a lot more convenient places. Anywhere where there are people gathering to do a lot of tech, there will probably be broken computers somewhere around there. And you can just say, hey, can I try and fix your hard drive? And a lot of time, it's like, what do they have to lose? If they just have a broken computer that they've given up on, and you could fix it, even if you don't fix it, they're going to be totally fine with that a lot of the time. So just ask around, look for places where there are tons of leftover computers. Something else I'm thinking of, I can't really remember at the moment.
Well, while you're thinking, we're going to end the video.
Oh, okay.
Grab clap in the video.
Thank you.